researchers in the Netherlands have begun nuclear fission tests using thorium salts, a method said to be far cleaner and safer than uranium-based systems. Dutch firm NRG has revealed a plan to test small-scale reactors that use molten salt as fission fuel, marking the first time scientists have embarked on such experiments since the 1970s. Experts say thorium is more difficult to weaponize compared to uranium and could even make for meltdown-proof reactors. Thorium is more readily found in nature than uranium and is not usable by itself in a thermal neutron reactor, as it's not fissile, according to the World Nuclear Association. But it is fertile, meaning it transmutes to uranium-233 when bombarded with neutrons. It's said that the use of thorium in molten salt reactors would produce less toxic waste in the long run and could be more easily reprocessed. This is a technology with much perspective for large-scale energy production, said Sander de Groot, of NRG. We want to have a head start once the technology will break through. We see this as a commercial opportunity for the long term. The first experiment will build off the concept of the waste-burning MSR, or molten salt fast reactor. This could, theoretically, be able to use spent fuel from typical uranium fission reactions, according to MIT Technology Review. The researchers planned to use 4 crucibles containing a mixture of lithium fluoride and thorium fluoride. These will be placed within concentric steel tubes, each roughly 50 centimeters high, according to Thorium Energy World. The tubes will then be brought to a radiation field of the high-flux reactor, where the thorium will then transmute to uranium, which will subsequently begin fission. The experiments across several small-scale reactor designs could pave the way for meltdown-proof nuclear power, Technology Review notes, as designs that use thorium in the liquid form would be self-regulating. Safety is high, due to passive cooling up to any size, the World Nuclear Association explains. Also, several designs have freeze plugs, so that if excessive temperatures are reached, the primary salt will be drained by gravity away from the moderator into dump tanks configured to prevent criticality. MSRs have large negative temperature and void coefficients of reactivity, and are designed to shut down due to expansion of the fuel salt as temperature increases beyond design limits. The researchers plan to stick to standard materials, such as stainless steel, for the experiments, unless it proves unsuitable. In the tests to follow, they will use a different mixture that contains beryllium, forming what's known as Fli-B. These will focus on the interaction between the salt and the containment materials. China has also shown interest in MSR technology, with plans to have thorium-based reactors added to the grid within the next 2 decades.